Hello, in this video we are going to talk about comparators. Let's get to it. So very important fundamentals is something called comparators. And that is one of the bases of all logic that you'll be building out. And with comparators, essentially what they are, comparators compare two items that will create a conditional logic, and it will always return some sort of a Boolean value. So it will either return either a true or a false. And there are many types of comparators out there. These are the most common ones that you see here. They do tend to vary depending on programming language and different programming language. So we have the equal by value and type, not equal by value and type, the less than, greater than, less than equal to, greater than equal to, and the symbol for and or. So these are the different types of comparators that you are going to use when you are trying to build out your logical statements. You might use a single one of these or a combination of these. Now, before we move forward and break down what each of these comparators do and what they are, I first want to address this here, which is the equal sign. In the real world, when we were taught, the equal sign means equality. But inside of coding, in most cases, this symbol doesn't really mean equality. It actually means assignment. So we need to forget that this means equality and think about it as being assignment. There are some rare cases, such as SQL, that will treat this as equality, but in most cases, this will be assignment. When we are using the equal sign, they kind of correspond with variables. This allows us to define a variable as well as reassign individual values of variables here. And with this, for example, we're using JavaScript here. We can create a variable and assign that to be this string here. So that is the assignment operator. And if we want to reassign it, we can use the same symbol and reassign it to a different value. For this example, we have a variable called time, and time is 12:30, and then later on in the code, we might need to change the time to 12:35. So that is assignment and reassignment. So this is technically not a comparator, that is for something else. You have three things that make up a comparator: your left comparison, the comparator itself, and your right statement. So on the left is what you are comparing. The comparator is the symbols on this slide. So these are one of the symbols. Again, these aren't all of the symbols as well as all the ways you can compare, but these are the most common. So that would be in here. So one of those will be here. And on the right is what you are comparing it to. So you need three parts to make up a comparison logical statement. If you are missing any single one of these, that will give you an error in your language, saying that you are missing a comparator or it doesn't look right, things like that. So a syntactic error. When we are comparing two items, there are a few things that we need to know. The first is we need to be specific. And the reason for that is that you can't just compare two things that are unrelated, such as if you're comparing an apple and an orange. That's not really specific enough. A better thing to do is that if we are comparing like the colors or the calories or the sugar levels of an orange versus of an apple, that is much more specific than just being very broad and very generic when you're building out comparisons. And also keep it simple. If you are comparing multiple items, then you might need to simplify it into having a multiple comparison. So we need to have it as simple as possible just so the logic will later on make sense. And then there's these next three terms here. So with these next three terms, these are terms that sound very intimidating and intense, but actually really mean something simple in the computer science world. So it is Tana Logical, Contradiction, and Contingent. So essentially when we are building comparisons, we need to be not tautological as well as not contradiction. And I'll tell you what those are in a bit. And a matter of fact, we need to make our statements be contingent when we do build out our comparison. So let's go ahead and break these two terms down a little bit more, just so we can understand what it takes to build out a comparison logic. First, let's talk about Tana Logical. What Tana Logical means is that it's always true in every single way. So no matter what the comparison is, it is always evaluated to true. Now, this is a bad way to write your statement because it will always run your conditional logic because it's always true. And we don't want that. That's not really a very good conditional logic. That really is one-sided. So as you can see here inside of this example, you can see that true is equal to true. This is one way you can write a tautological statement, because this statement and this statement, they're both the same thing. Thus, this is always true. So this will always be true. There's no way for this to be false. So this is a tautological statement. And we don't want that in our comparison logic. And then there's also something obvious like this, is that 5 is not equal to 6. Well, this is always true. No matter what, 5 is never equal to 6. So this is another way you can write tautological statements. So be careful. There's multiple ways you can achieve this. If it always evaluates to true, then you need to rethink how you write your logic. So we don't want our comparison to be tautological or always true. The opposite of tautological is a contradiction, and this is always false in every single way. So this is where you are having some sort of a logic, and no matter what, that condition will always evaluate to false. And the reason why we don't want this is that whatever this is paired off with, it will never be run because it is always false. Usually when items are true, that's when it's run, but when it's false, it is never run. So we need to be careful with this too. Some examples we have here, we see that true is equal to false. This is always false, as well as 5 is equal to 6. This is always false as well. And since there are always false, then this will never run when it is paired up with any other statements or loops. So that is why we can't write our items to be contradiction or to be always evaluated to false no matter what. We need some sort of a way so we can have a balance, which goes into this term, which is contingent. And essentially what contingent means is something that isn't tautological and is not contradiction. So it means that on both of the cases, or whatever your comparison statement is, it could be true or it could be false. It's not always true and it's not always false. It could be either one of those. So that is what contingent means, because it allows you to have the option for the input to be either true or false. And that's something that we need when we evaluate conditional logic. So for the left side, this is actually a bad example. The reason being is that we are comparing apple to oranges here, such as we are comparing a person to be equal to string of Bob. Well, that's not really specific enough, because what are we comparing the person on? Like, are we comparing them to the name, or are we comparing it to something else? So that's why we need to be more specific when we write our comparison statements. So this is a better example, and this is also contingent, because the person name, now we know that it's the person's name is equal to the string of Bob. So we know that this is what we are looking for when we are comparing. But we know that we're looking for the person name, and we're seeing that if it equals the string of Bob. The other thing is that it could be true or it could be false. The person name could be Bob, and that will evaluate to true, or the person name could be something else like John, Jill, etc., and that would be false. So that is a way where we should write our statements, so it has the flexibility to be true or it could be false. So remember, when you are making a comparison, be specific, make it simple, make sure that you don't always have it be true or tautological or always false, which is a contradiction. And be sure to have it be contingent, which is neither of those previous items, like so. So now let's go into the individual comparators that you may or may not be using. So the first one is a double equal sign. Again, remember one equal sign means assignment. It doesn't mean equality. What does mean equality is two equal signs here. But this is only equality in value. What I mean by this is that if the two values are the same, then it will evaluate to true. It doesn't matter the data type, it will always still be true if the two values are the same. And then we also have the not equal, which is the opposite of this. If it's not equal in value, then you get some sort of a conditional logic like so. So for example, with the equal in value, you can see that 5 is equal to the string of 5. As you can see here, since the two values are the same, 5 and 5, that will evaluate to true because this really cares about the individual value. And obviously this one will give you false because they're not the same. This is the number 5, that is a string, and also that is a h and that's a 5, so that will give you false. Now if we go into not equal, we can see that with not equal, we have 5 not equal a, that will be true because it's not equal. But if we see this will be 5 is not equal to a string of 5, that will give us false because technically that condition is true because it is the same values. So just note that this is equality in the value, which is what the value is inside of a string or the individual number. Whatever the value is, it compares it with equality. In most cases, when you are using equality, you might need to be more specific. And that's where this comparator comes in. This is the triple equals. And this is equality in both value and type. And the type means is both value and data type. So they have to be exactly the same value as well as the exact same data type too. So if we bring back the previous condition, you can see that the 5 in the string of 5, this is false. Even though they have the same value, they also need to be the same data type. So that is why this will evaluate to false. But here we have 5 equal to 5. That is true because they're both the same value as well as type. And this means the opposite. That is not equal in value and type. So this condition is true because 5 is not equal to the a term here, and this one will also be true as well because it's not equal to the value and the type. So when you are using equality, you need to be more specific and make sure that you have both equality in value and type. So for the next few terms, you probably recognize these from your math class. And this one is the less than term. Essentially, so this works very well when you are comparing numbers. If you have to compare values such as strings or any other data type, you might have to write the comparator yourself. But in most cases, this makes the most sense when you're dealing with numbers. Essentially, it checks if the left side is less than the value on the right side. And this one is less than or equal to. So it checks if the left is less than or equal to the value on the right side. So 4 is less than 10. That statement is true. 3 is less than 2. That condition is false. And 4 is less than 4. It's technically false because we're not including the 4 here. It has to be less than 4. So this is inclusive of the number here. So that is why this is false here, because it has to be strictly less than. But if we try the same thing but with the equal sign, less than or equal to, then we are inclusive. So we are including the 4 here. So that is how we get a true statement when 4 is less than or equal to 4 here. And then with 7 less than or equal to 2, that one will be false because of the obvious reason of it's not less than. So these are pretty simple and clear cut. Again, you might see these with other types of comparisons with strings as well as other data types, but with those specific cases, you may have to write your own comparison. You might have to compare it in a way where you have to have a less than or greater than, depending on alphabetical wise or depending on some sort of ordering system. So that is what you would do if it's a different data type other than numbers. But in most cases, you would use this with numbers. So this is very similar to the last one, where this is kind of technically the opposite. And you might get two of these confused. Just know that whatever the alligator mouth is, it goes towards the bigger number. So this one is greater than. So this one is greater than, this one is greater than or equal to. And as you can see here that the first one is not including the 2, so it's exclusive. And this one does include the 2, which is inclusive. So this one will evaluate to true, where this one without the equal sign will evaluate to false. So 1 greater than 0.2, that one's true. This one will be false because 2 greater than 22 does not make any sense at all. And our last statement of 8 greater than or equal to 6, that will also be true as well. So you will be using this very similarly of how you would use the last one. The next 2 aren't necessarily comparators. They're actually something to help with creating comparison logic. And with this, these are the 2 and symbols here. So 2 of these together make an and the opposite is or. So that means and. Essentially what this does is that if we have 2 different types of comparison statements, both sides need to be true in order for the and statement to be true as well. So if one of those are false, then it will always evaluate to false. So both sides need to be true with this particular case. For example, if you have 2 comparison, we have our first one here and then another one right here. We can connect those with the and. And you can connect even more with the and as well. But it does things from left to right. So this one needs to be evaluated to true, which it does. And this one also needs to be evaluated to true, which it does. Therefore, the whole statement with the and is true. If we look at this example, 5 is less than 2. That one is false. And if it's false, then it might skip this condition depending on your programming language. But this will evaluate to false because not both of these sides on the left and the right are not true. So that is the and here. So a better use case of how you would be using this is maybe to set a range for some sort of user input. So for the user number, we have user number greater than 0 and user number less than or equal to 10. So we can actually use this to set a range if we need to as well. And both of these cases have to be true in order for the condition to be met. So that is the and, to make sure that you have both sides to be true, otherwise it will be evaluated to false. So with this symbol here, this is the or symbol. And with this particular symbol, I just leave a space in between it for you to easily see it, but usually there's no space there. I just did it for formatting's sake. It looks a little bit weird when it's no space, but just note that they're right next to each other. And the symbol here are called the pipes. And with the pipes, they're actually right above the return button, and you have to press shift in order to produce that on your keyboard. 2 of them make up the or symbol here. And with the or symbol, at least one side of each of the statements on the left or the right of the or needs to be true in order for the whole entire statement to be true. So for this particular case, this side is true as well as this side is true. We just need at least one of them to be true in order for this whole line to be true, which it is. But for this particular case, both sides are false, right? And that is why it evaluates to false. So if we have a single case where it's true at least, then it will be evaluated into true. A good example of this is if we are trying to look for items for a user, such as if the username equals Bob as well as the user number equals 10. If either of these conditions are met, then we would run our logic. But if none of them are met, then we would do something else. We wouldn't run the logic here. So that is the or symbol. Very similar to the and symbol, but only one side needs to be reproduced. In our next couple of videos, we'll be doing videos on loops as well as statements. And we'll be using comparators to help set up different types of loops and different types of statements. And with those particular comparison, we are comparing them using these symbols that we learned earlier. And that will evaluate to true and false. And depending on if it is true or false, we will do some sort of a logic right after, using loops as well as conditional statements. If you liked the video, don't forget to like, share, and subscribe below, and I will see you in the next video. See ya!